Okay, Assalamu alaikum. Good afternoon, everyone. Welcome to the lab class. Yeah, okay, thank you. So today, yeah, okay, fine. All right, okay, thank you. Today, so it's about experiment number 7 according to the lab manual, part 2. So part 1 and part 2. So in the part 2, you can see according to the lab manual, part 2. Experiment number 7. So DC motor operation control by microprocessor. You already have seen that in the application board, we have a DC motor with a propeller. There is a fan type something. So if the motor is running, that means how can we realize it? That you can see that the fan is moving on. Okay, so now it's about this experiment is related to the operation control by 8086 microprocessor. So what sort of operation or how can we control it? So uh, it is like, okay, let me draw the figure. The figure, okay. Okay, I'm drawing something, so wait a bit. Yeah, I'm drawing something. Just wait a bit and then I will discuss it. So you can see, right? What I'm drawing, you can see it, right? Okay, fine. So okay, now look at here. So like we have a two switch. They are connected with 6 and 7. 6 and 7 of port A. So that means if it is like a port A, if it is a 8-bit, port A is 8-bit, right? All the ports are 8-bit. So 8-bit, yeah. So this is for port A, for example. Port A, yeah. So 0 to 7 bit. So 6 and 7, they are connected with a two switch. They are connected to a switch. Okay, they are connected to a switch. For example, this one is S1 and S0. Okay, okay. And now it's about the port B. Port B is connected to the motor. So DC motor actually it has two terminal. Okay, so if for two terminal DC motor, it is port B. Okay. Yeah. So motor is connected between these 2 points. Okay, 7 and 6. Okay, so others are we are not using, right? This 0, yeah, this is 0 pin. So 6 and 7. So motors are connected here between two terminals. Port B, 6 bit number 6 and 7 is connected to terminals of the motor, DC motor, and port A has two switches S1 and S0. They are connected here. So how actually control it? What is the purpose of this one? Like for example, S1 and S0. These two switch. Okay. So if it is if they are 0, for example, if they are 0, motor is off condition. For example, motor is off. If it is 0, 1, motor moves clockwise, clockwise, for example, clockwise movement or forward movement, for example, clockwise or forward, and 10 anti-clockwise or reverse, you can say reverse or anti-clockwise. say counterclockwise. You can see CW counterclockwise. Okay, or you can say clockwise. You can say forward. FW forward. Or here you can say reverse. Reverse. Okay, and one, for example, it is off. Again, it becomes off. So that means switch is actually controlling the operation of the motor. Okay, it's not about the speed, controlling the speed. It's about the control of the operation. I mean, make it on, off, and on. Is it clockwise or anti-clockwise? Something like, or it is forward or reverse. So problem is clear. Is it okay? What is the experiment for today?
Can you repeat the last schedule that you draw?
Which one? Okay, I am repeating again. So here in this experiment, we have a motor and we have switch. Switch, actually, the switch to switch S1 and S0, they are connected to, you can see they are connected to port A, bit number 6 and 7. And it is also, I draw it here on the top here, you can see. So port A, it is 8 bit, right? 0 to 7. So 6 and 7 is our point of interest. Other bits are not, we are interested of. So 6 and 7. So for example, the switch at 6 is S0 and the switch at 7 is S1. And we have a motor, it is connected to the port B, 6 and 7 bit. So we can draw the like port B, 8-bit port B. It is a later part. So to try to understand this one first. What is the problem here? So and then motor is connected to the 6 and 7. So 6 and 7 bit of port B. So port B here actually. So that means motor is connected between 6 and 7. This is what I actually want to mean. Here it is motor. Okay, motor is connected here. And what actually motor is connected here between 6 and 7. Okay, so the connection is okay, right? Connection, hardware connection is clear. Okay, now next is about control. So what sort of control we want? We want that if switch to switch, if it is 0 0, motor is off, and if it is 0 1, motor moves in clockwise direction, clockwise or forward direction, FW or CW. CW means clockwise, or FW means forward. Okay, and 1 0 in counterclockwise, CW, counterclockwise or anti-clockwise or reverse, you can say reverse, and 1 1 it becomes off again. So look at here, how can we keep the motor off? If we give 0 0 on the both terminal of the armature, you know motor is like armature. If the voltage are same 0 0 or 1 1, then motor is off. Okay. Okay, get it back. Here it becomes a okay, let me draw it again. Okay, so it is, we have a S1 and S0 two switch. Okay, S1 and S0 two switch. Okay, and this is motor both terminal, motor two terminals, they are connected to the 6 and 7 bit of port B. And what sort of control we want? If S1 and S0, okay, if S1 and S0, if it is 0 0, motor is off. If it is 0 1, clockwise. Clockwise. If it is 1 0, counterclockwise. If it is 1 1, then it becomes off again. For example, this is our the switch is controlling this way the motor operation. Okay, so now the problem is defined, right? Is it okay, right? You do understand this one? Is it, the problem is clear? Problem is clear? Okay, okay, now look at here. So now you know you know that how can we make the motor off if we give the both terminal of the armature same voltage, either 0011, motor will be off. And clockwise, if for example this one is 1, this one is 0, and motor, for example, it moves clockwise. If we send here opposite thing, like this one is 0 and this one is 1, then it will move opposite wise. Okay, so counterclockwise. For example, if 7 bit is 1 and 6 bit is 0, and if motor moves clockwise, for example, so if we give 7 bit 0 and 6 bit 1, it will move anti-clockwise. That's it. And also, you know, port or port B, for example, port B. So 8 bit, right? Port B. So this is for port B. And motor is connected between 7 and 6. Port B output port, yes. Port B output port. And port A is input port. Yeah, so port A, it is connected to the switch. Switch actually controlling input. It actually controls the operation of the motor. So this is 7 and 6. So 7 is S1, for example, and 6 is S0, for example. Okay, so this is about that. Now about, so first of all, we have to find the address. We know already the addresses of port A, port B, port C, and control register. And then what actually we have to do, we have to find the control word. What is the control word here? Control word. Oh, okay. So let us draw it. So control word 8-bit, right? 8-bit. So what will be the, so this is for PC low. PC low. This is for port B. Okay, and this is for mod. And then this one is for PC upper. And this is for port A. And this 2-bit is for mod. And this one is by default 1. Okay, now look at here. So port C is unused here, so it is don't care. Port B is used here and it is output port because motor is connected here. Output port, and mode is simple input output mode, so mode is 0. And port C upper is unused. Okay, and port A is an input port. Okay, so port A. Yeah, okay. Port A input port and mode 00. Okay, so now what is the control word? If 0, I mean don't care cases are 0, then it will be 90. 90H, or if don't care cases are 11, then it is 9H hexadecimal. Okay, so now it's about writing the program. Okay, let us write the program. Dot model small and then dot code. And now we can define the define variable for the port A, port B, port C addresses. For example, PA EQU 00H, port B EQU 02H, port C EQU 04H, and control register EQU 06H. So actually port A address is 00H. We define a variable PA here. We define a variable for 02H is PB, PC and CS, so on. Okay, and then now it's about we have to send the control word to the control register first of all. So then that means move AL comma, what is the control word? 90H out CR. So control register address is 06H. We can write directly 06H comma AL, or we can write as we define a variable CR. we can write CR here. All right. So that means this is about initialization. Control word is I mean we initialize the variable for the port addresses, and control word is sent to the control register. So this is we must have to do at the beginning. Then what can we do? We have to, okay, so then so switch, we have to read the switch, because switch actually control the operation of the motor. So what is the switch condition? How can we read it? So in, right, in AL comma port A. So port A address is 00H. We can write 00H, or we can write A. So in move doesn't work here, because for input output cases we have to write in and out. For input cases, in AL comma 00, AL comma port A. Okay, now look at here, port A address. Port A, we are interested about 6 and 7. Other bit are actually we are not interested in, because this is not our point of interest. What they are, we don't care. What the other bits are, don't we? So that means we have to mask off these bits. Okay, this 6 bits, 0 to 5. 0 to 5, we are not interested about this thing. We are only interested about 6 and 7. So how can we mask other bits? You know, we can mask it using AND, logical AND, A and B, and AL comma. So only AL comma 1 1 0 0 0 0 0 0 B. So that means only all the bits are 0 0. So if we make the AND operation, AND operation with all the other bits 0, then they what are the situation of there? They will be 0. Only they will S1 and S0 will be what they are. So this is the AND operation. So that means it is the way we can mask off the other bits 0 to 0 to 5. Is it clear? Masking off. Yeah, so we can write 1 1 all zeros, or we can write C0. This is okay, both are okay. So this one, or we can write like 0 C 0 H. Yeah, both are okay. Okay, now in. So now it's about we are interested about S1 and S0. So this is S1. This is S1. Sorry, this is S1. S1 and S0 switch condition. Okay, so it's not. So then, so now we can, if so compare. So how can we check it? Compare AL comma, if S1 and S0, if they are 0 0, that means all other bits are 0 now. If S1 S0 they are 0 0, so that means compare AL comma 0 0 H. Is it 0 0 H? Then we'll go to jump equal, we'll go to a subprogram of a label. Okay, if it is not, then compare AL comma. So now if S1 and S1, if it is 0 1, if it is 0, sorry, if it is 0 and it is 1 and others are 0, okay, so it becomes like 4 0, right? So 4 0 H. So if compare AL comma 4 0 H. Okay, so compare L comma 40 is. If it is if it is jump, do a jump if it is equal. If equal, we will go clockwise and a sub program or another level. If it is not, then compare AL comma. So now if this one is 1, it's not a 0, it becomes 80. 80H. Jump equal. If it is equal, then counterclockwise. There will be another subprogram. We will go there. And if it is not, then okay. So now if it is yeah, then compare L comma. If S1 and S0 both are 1 1, then it becomes C0, right? It becomes C0. So 0 C 0. Yes. It is okay. So it will do S1 and S0. If it is 1 1, then it will do the off operation, off. So already declare off. Jump equal O F F. Okay. So we have out of 4 action, out of 3 action, either off or clockwise or counterclockwise. We have to do it, and then actually yeah, these 3 action, it will be written separately. Okay. So after that, so then it will do the things again and again. So that means then jump ARP start. Where is our start? Start is here. Yeah, here. So jump start. Okay, so now look at here. What about the clock off action? So we can write the off action here. What should yeah, off. What actually will do? Move AL comma. How to make off? So between 6 and 7 of port B. So if we send 00H and out port B, motor is connected to the port B. So PP comma AL, that means it is off. Okay, and then JMP, jump, start again. Start. It will do continuously, you know, continuously it have to check the switch condition. Okay, then what about the clockwise? Move AL comma clockwise. Yeah, it doesn't matter, clockwise. So if it is like for example clockwise, it is 0, it is 1, motor moves clockwise, then what will be our others? If others are 0, so others are 0, so that means 0 1 all are 0, so that means 40 is out port B comma AL, and then it actually then again go to the start, because it always need to check the jump switch condition. What are the switch condition? JMP, jump, start. Okay, and then again for counterclockwise move AL comma So 1 0. Okay, 1 0 means 8. 80H. Out. Port B, comma AL. That's it. And then it's a J and P jump. STR jump start. And that's the end. E and T. End. Is that okay? This is the end of our program. Yeah, so any question do you have here? So this is a like a it's switch. Using the switch, we can control the operation of the DC motor. So yeah, so DC motor. So it's basically we have switch and we have motor, and so switch. First of all, actually we use here, we initialize the variable. The port addresses are assigned to the variable. We can use the variable PA, PB, or we can use directly. And then control word is sent to the control register. Okay. And then we have to read the switch in. This is the beginning part. Start in AL comma port A. So then now mask of the all bits except these 6 and 7. How can we mask it? So 1 1 and all the bits are 0. So we can write it in a binary format, or we can write it in a hexadecimal C0. So C, definitely we have to put a 0 before C. C0H. Okay. So do the AND operation. And now it's about compare. Compare AL comma 0 0. If it is 0, because if S1 and S0, if they are 0 0, other bits are already 0. So that means if it is 0 0H, we will perform the off operation. If it is equal, jump equal off. Where is off? Off is here. How actually it makes the DC motor off? Just sending 0 0 this 2 bit. If it sends 0 0 here, because motor is connected between 6 and 7, we send 0 0 here, or 1 1 also it okay. 0 0 here, port and send it to the port B, then it is off. Then again jump start here, because it always need to check the switch condition. Jump start always. If it is same, then it will come here. Okay, now it's about switch condition. Another switch condition 0 1. If it is 0 and it is 1, then and other bits are already 0, that means it becomes 4 0. So compare AL comma 4 0H. If it is equal, do a jump to another levels. CW for clockwise. How can we make the motor clockwise? For example, this one is 0 and this one is 1. Motor moves in clockwise. So it becomes 4 0H. And send it to the port B, and then jump start again. Because to check the switch condition again and again. If it is in the same condition, it will do the same work again and again. Okay. Then then we compare another condition 1 0. S1 and S0 1 0. That means this is 1, and this is 0. And if it is like that, others are already 0. That means it is 8 0. So compare AL comma 8 0. If it is equal, then do a jump in counterclockwise. CCW. And how actually we make the counterclockwise? Clockwise, if it is 0 and 1, it moves clockwise, then definitely 1 0 moves the counterclockwise. So that means if it is 1 and it is 0, and other bits are actually we don't care about this thing. For example, they are 0 0. So that means it becomes 8 0. Send it to the port B. That means motor moves in opposite direction. And jump start, actually it actually check the switch condition again and again. If it is the same situation, it will work the counterclockwise. And what is the other thing is, if switch are 1-1, then it makes the motor off. So 1-1 means, if you look at here, if it is 1-1 means C0 H. So if it is C0 H, jump equal off already we declare, so we don't have to write again. Okay, and then jump start again. It is the continuous process, and this is the end. Any question here? No, so actually, so but as it is online, so how can we check the practical work? But definitely, when actually the things will start, I mean, if the I mean, if lab class will back to the physical again, then you may check it. Or otherwise, actually, this is also like, this idea is also we can use it for final exam, because it is part of the theory also. So hopefully it is clear. If you have a question, raise it now, or otherwise we will finish it. Okay. So, and other thing is, Thursday you have the measure. Thursday, as you have the measure, so at top page, fill up the top page with your name and ID, and keep it with your solution. The solution that you send me at the beginning, keep the top page also. Okay, that will be better for me. So with your solution, keep the top page, and handwritten solution, and yeah, that's it all about it. And so it's 12 to 2, so you should finish it before, you should finish it before time finishes. Okay, so careful about it. All right, so any question? Yes. Yes, Abdullah. Yeah, so take 5 minutes, 5 minutes for uploading. Okay, so that means time is 1 hour and yeah, 1 hour and 55 minutes, and 5 minutes for uploading. Okay, so think it like that way. So think it, exam time is 1 hour 55 minutes and 5 minutes for uploading. All right. Okay, I will see. I'll see what can I do, what can be done. Who is absent today? I can see 2 of you are absent. Who is 2? Mokbil is absent, and who else? No connection. It's showing no connection. Why no connection? Okay, so no, I see 3 of you absent. Okay, let me check it. Amod is here. And Bandar. Yeah, Khalid is here. Beta. Okay. Thanks. Okay, so I can see that Abdul Karim is absent and Al Walid is absent. So Mokbil, his connection is showing no connection. Anyway, all right. So this is all for today. So do you have any question? Yeah. Okay. So this is if you are back to the lab, then we will test it on the lab. Otherwise, this is also part of the lecture class also. This is also part of the lecture class. You should understand it, and you should understand, because like switch may be changed. Like instead of 6 and 7, it may be connected to another pins. So you have to understand. There is nothing you have to memorize. Okay, you do understand. You need to understand the things. Okay, that's all.